I think we can go ahead and get started. Welcome everyone. This is Introduction to Git and GitHub. Like I said just a minute ago, this will be a very kind of introductory session on using Git and GitHub. We probably won't get into collaborating in GitHub, which is in Alder 103 next door. But if you feel like you would rather be in that session, like I said, feel free to walk over whenever. We're not going to be offended if you find yourself in the wrong room. Okay, so I'll give everyone a minute to kind of trickle in here. But we're going to be doing this tutorial in the Jupyter Hub. That's partly because Git is already installed there and we've got it partly set up for you. That said, you go through some of this material on your own for your own laptop, for example, if you want to use Git on your own laptop. And for that, I'm going to go ahead and start by pointing out where all of this lesson material comes from. So you may recall Russ mentioning software carpentry yesterday as a kind of handy resource for a lot of these tools. So if you go to software-carpentry.org/lessons, that's where I am right now on this site here. You can also just Google software carpentry lessons. You'll come to this page and they have this section here, core lessons in English and then core lessons in Spanish. And in particular, the second one is called version control with Git. And if you click over to this site, it'll take you to, I believe, this page or one very similar. And
sorry to interrupt you. I cannot see anything.
Oh, I'm sorry. I forgot to share my screen.
Yeah,
My mistake. Sorry about that. Let's see if I can hide this. Okay. Sorry. So we went to software-carpentry.org/lessons, and then there's this version control with Git down here, a little ways down the page, and you can click to this site, and that'll open up this this lesson on Git and GitHub. Now, this lesson is the software carpentry lesson on Git and GitHub, and I'm going to be giving a similar lesson, but not an identical lesson. However, most of the kind of critical stuff that I'll be covering is also in here. So if you want to come back to this and go through a lot of it on your own laptop, for example, or if you just want to come back and review at some point, this is a good resource page. That's pretty much just why I'm showing it. Additionally, it has a few little images and animations and stuff that I'm going to use. So in particular, you've probably all been in some kind of situation, at least vaguely similar to what's shown here in this comic, where maybe you're writing a paper with your advisor and you write it as a Word document and you send it to your advisor and your advisor prints it out and writes on it with a bunch of red ink. That's probably not as common as it used to be, since now you can put comments in Word documents, but it used to be that this was always how your professor wrote on your comments, was red ink on a printout. And then you would go back and you'd revise it and you'd make a new version, and you would repeat this until basically your professor got tired of putting comments on your paper. And then eventually you'd submit, but in the process, you made all these copies of this document, and it was very hard to tell which version went with which particular point in time and what changes were in one document versus another document. And it was just kind of a messy way to keep track of anything. Git is kind of a solution to this problem. It is a system for tracking changes to documents and files. It's a system for collaborating with people on files, and it solves a lot of the problems that come up in this comic very elegantly. Now, one of the things about Git that makes this possible is that it doesn't save files the way that Word saves files. When Word saves a file, it writes out this great big block of, I think technically XML, which is a bunch of like encoded information about whatever's in your file, including things like images and if you have animations or tables or all that kind of stuff. It gets saved in this kind of binary format. And if you then add a line and you resave it, it just resaves a new version and it throws the old one away. In Git, if you start with a file, let's suppose you start with a text file, and then you come along later and you edit it, what Git actually does is it takes that edit, which is represented here by this dashed line, and saves, it basically saves this edit and where you put it in the file as sort of an appended piece of the file. So it keeps track of what you originally had, and then it saves what changed. And when you go and add more lines later, it'll add those to the file and it'll save what changed, but it doesn't erase the old version. So what this means is that if at some point in the future you come along and you want to know what you did 2 weeks ago, you can rewind Git and say, I want to go back to 2 weeks ago. And it says, well, since 2 weeks ago, you made these changes. So I'll just ignore them and give you whatever you had 2 weeks ago. This is sort of a strategy for saving progress in these kinds of files, where you basically save what are called patches or changes over time, and it makes it very easy to look back at history. Similarly, Git is very good at managing this kind of specific situation where you start with some particular document like this one here, and 2 people are editing it simultaneously. And maybe I'm editing it and I change this line here while you're editing it and you add a couple lines at the end. If we were to do this in Word and you were to send me that Word file where you would change things, I would need to go and manually say, oh, okay, these are 2 additional lines. I need to add them to the end of my file. Git will do this for you. It's very good at solving these kinds of situations where people have edited things simultaneously, and it can just kind of resolve those, usually without even needing your help to do it. Now, this is all kind of stuff that they're going to be talking about next door, and that's okay. To be honest, Git is a really big program. It does a lot of things for a lot of people, including great big corporations where like their entire code base is managed in GitHub repositories or and using Git. And so Git has a lot of features that we are not going to talk about and that we're not going to get to in these lessons, and that's all fine. Really what we want in this lesson is for you to get comfortable enough kind of using Git that you have a sense for what it can do and how it does things, and such that like next week during the hack projects, even if you don't know exactly how to do some particular piece of collaboration in Git, you know enough about it that we can just come and kind of guide you through it very easily. So I don't expect you to be experts on Git at the end of this. I just expect you to kind of have a good intuition for what it can do and how it works. Okay. All right. So like I said, there's a whole lesson here. It's a good review if you want to come back to it later. I'm going to come over to our Jupyter Hub now, though. And for starters, if you just opened the Jupyter Hub, you should get a launcher like this. And I think you've all seen opening up a terminal using this. And we're actually going to use a terminal for pretty much everything in Git. Git does not really interact directly with Jupyter, but it's typically a command line tool. So we'll be using the command line. All right, so let's just start with a very simple command. First of all, let me make this a little bigger. And I'm going to hide this tab. All right, can everyone read that okay? Okay. All right, so I'm going to start with just a very simple.
Sorry to interrupt. Can you tell me how do I go there now? Because I'm here where the links are for the Zoom rooms, but I don't know how to go. Sorry about that.
So you should see a plus up here like this.
Yeah. Oh, okay.
So
okay. Yeah.
Yeah.
Okay.
Yep.
Okay. Thank you. Sorry, I missed that.
No problem. Okay. So we'll just do a simple command, git -- version. And that's just going to tell us our Git version. And that's just basically a test that it's been installed. And if you're doing this on the hub, I really hope this doesn't give you an error because I don't know how to help you if it does. If you want to do this in your own terminal because you want to set up Git on your laptop, that's okay. It's just that I may be skipping some stuff. And so that's maybe something better for us to do offline later next week, but feel free to try. It should mostly work if you do it that way. Okay, so like I said, Git is a very big, complicated program. So we're going to start by setting up some configuration settings before we go too far here. So we're going to start by using a subcommand, git config. So Git operates with subcommands. Pretty much anything we do in Git will start with the command git right here, and then there'll be a space and there'll be some other command that we'll add. So in this case, we're using the git config subcommand, and we're going to use this flag global that just says I want to configure what I'm doing here is I'm going to configure something, and I'm going to configure it for every time I run Git, not just this current session I'm in. So we want to go ahead and say git configure global, and we're going to say user.name. And then in double quotes, you're going to put your name, not your GitHub username, but your actual name. So I'm going to put Noah Benson. And then after that, this is just telling Git who we are. We're going to do another one, git config -- global user.email. And in quotes, you're just going to put the email address you used when you signed up with Git. And I think mine is nben@uw.edu. Okay. Now we're going to do one more, git config -- global. And this one is init.default branch main. This one probably isn't necessary, but it's a good one to run anyway. When they originally wrote Git, Git has this concept of a repository, which is just some files you're keeping track of. And you can have multiple copies of that repository where you've made different changes. For example, maybe you're working on adding some feature or maybe you're working on a paper, for example, and you've made a copy of your repository where you're working on like the methods section or something like that, while someone else has made a copy and they're working on the results section. Those would be two different branches of that repository. Git has a concept of a main branch. When they originally wrote Git, they called it the master branch, and they've since moved away from that term. So by setting this setting here, we're basically telling Git that we want to use the main terminology, which is kind of the standard these days. Okay. Since we're setting this up on the hub, this is all we need to do right now. If you were using this on Windows, there are some other configuration options that are mentioned in that tutorial page that I showed you earlier, but we're not going to worry about them for now. Now, if we want to see our settings, we can run git config -- list, and that'll show us all of our current settings. So you can see the 3 we set here, and then you can see some other stuff up here that has to do with credentials. That's kind of Jupyter Hub magic that we're not going to worry about. Just as kind of a general piece of information here, most of the Git commands, in fact, I think all the Git commands accept the argument -- help or alternately -h, and they'll give you help text that basically explains how to use the command. You can also type git help. Oops. So for example, git help config, I believe. Nope. Okay. That's not going to work. And the reason is because there's a Unix command called man, which stands for manual, that apparently isn't installed on the Jupyter Hub that Git uses, but that's okay. You can always use git config -- help or git config -h. Okay. So that's some basic configuration. Now, so Git, the command, is not the same as GitHub, the website. Now, they're very closely linked, but they are not the same thing. In fact, GitHub is just an instance of a Git server. A lot of companies, for example, have their own Git servers that they run in-house so that other people can't connect to them. But GitHub is by far the most popular and commonly used Git server, and it's where most people store open source software, and so it's the one that we tend to use. And so, in fact, I would be surprised if very many of you end up using servers aside from Git, at least in academia. So we're going to focus on GitHub, and we're going to take a pause on the terminal for a moment and go over to GitHub for a little bit. So if you would just go to github.com. And if you aren't already logged in, go ahead and sign in with your username and come to this page. And what we're going to do is we're going to set up some authentication stuff with Git that we need to do before we can really jump into anything. So while everyone logs in, I'm just going to explain really quickly what kind of the concept that we're doing here is. Basically, when you're in your command line over here, you want the Git command to be able to talk to GitHub. You want it to be able to go to GitHub and download someone's repository or download your repository. And once you've made some edits to your files, you want to be able to push them back up to GitHub so that they're saved online. To do that, you need your Git command to be able to authenticate with GitHub. And it used to be that we would just type our username and password at the terminal, and that's how you would authenticate, but that's not very secure. It requires either you to type your password or it requires you to save your password somewhere on your computer. And so in the last few years, Git has implemented a bunch of rules. You just can't log in that way anymore. You have to use what's called an SSH key. There's actually other ways to authenticate with Git, but they tend to be more complicated. So we're going to use the SSH key method. It's also kind of the standard way of doing it. All right. And give me just a moment because I want to make sure I don't screw up any of these commands. Check my notes here. Okay, so okay, so the first thing we're going to do is we're going to go, sorry, once you've logged in, you should see a little icon up here. It may not be your picture, but it will be some kind of graphic. Go ahead and click on that, and you should get a menu which includes settings. So go ahead and go to settings. Again, that's you click on your whatever icon's up there and go down to settings in this menu. And once you get to this menu, you should be able to find an item on the left that says SSH and GPG keys. So we're going to go ahead and click into that. Now, once you've clicked in here on this SSH and GPG keys, you will see something like this page, although you probably will not have these entries here. These are entries I have. So the idea here is we're going to use what's called public key encryption with GitHub. A real quick explanation of what this is. Almost all modern cryptography is based on the concept of public key encryption, where basically I will generate a public and a private key that are linked in a particular way, and I will publish my public key for everyone to see. And if you have my public key, you can take any message or text or whatever, and you can encrypt it in such a way that the only way to decrypt it is by using the private key. So I keep the private key, everyone can see my public key. That means anyone can send me a message that only I can read. On the flip side, I can write a message and sign it with my private key, and then anyone with my public key can verify that whoever signed that message had to have had my private key to do it. So it's a way of both assuring that you know who you're talking to and assuring that nobody can read stuff but them. So we're basically going to set this up with GitHub, and the way we do that is we generate a private and public key pair on our computer, and then we tell GitHub what the public key is. And that's basically what we're going to do right now. Okay, so let's go back over to our terminal, to our Jupyter Hub terminal. And we're going to use a command ssh-keygen. So this is the command to generate public and private key pairs. And we're going to use an argument -t ed25519. I believe that is right. Okay. So if you type that command, and I'm going to highlight it here so you can see it. Basically, this is saying generate me a public and private key pair. Use a particular algorithm to generate this public and private key pair called ed25519. I don't know what ed25519 stands for. It is the name of some key generation algorithm. And then what it says is, where do you want me to save this key? The typical place to save these is in the .ssh directory, which is a hidden directory in your home directory. This is perfectly fine, so you can just push enter at this prompt. Now, it's going to ask you for a password. It might seem intuitive that you would want to put a password on your key. However, you don't. And the reason is because what this is actually asking you for is, do you want to have to enter a password just to read this key? Since this key is going to be stored on your local account and no one else is going to have read access to it, you don't need to do that. Also, this is just kind of a throwaway key for you to use for these 2 weeks, so it's really not that important. To be honest, I would only password protect my key if this were a shared login where someone else were logging in on the same username. But since that's not the case, you can just push enter here and enter again, and it will give you, it'll generate your key. It prints out this random arc, which is something about the random algorithm it uses to generate the key. I really don't know what the connection is. It's different every time you generate a key, but it's really just a gimmicky visualization. Okay, so now if I type ls:/.ssh, just for review, ls is the list directory command. Yeah, go ahead.
Okay, sorry. If I entered so I did the command SSH keygen, the -t in the PD, and then I just pressed enter, and then I somehow created a PD.
So that's fine. It probably created an RSA key, like ID_RSA for you.
Yes.
Yeah, so that's fine. Just retype this. It'll generate a new key with a different file name. You'll be fine. Yeah.
Okay.
Yeah. I actually think you are allowed to use the RSA keys. I just think these are more secure, and so that's why we use them. Yeah. Okay, so ls is the list directory command. Tilde stands for your home directory, and then /.ssh is the directory that these keys were put in. So if we list that, we'll now see, you see this known hosts file, which we can ignore, but we have ID_ed25519 and the same file .pub. So this .pub file is the public key, and this file contains the private key. I'm going to go ahead and just cat the public key, because there's really no risk of me sharing the public key with all of you. I'm literally going to go publish it on GitHub. And you'll see that it just contains this like tag SSH-ed25519, and then a bunch of gobbledygook. This is basically this text right here is a sort of binary representation of the actual public key itself. And what we're going to do is copy this whole line. And I'm just going to literally command copy on my Mac with Command C. However, if you're on a Windows machine, use whatever keys Windows uses to copy things. And we're just going to take this key, go back over to our GitHub page where we have the SSH keys, and push this new SSH key button. Let me make this a little bigger. Right here. Is everyone with me? I don't want to get too far ahead here. Okay.
No, oh,
Yep.
sorry to interrupt again.
No problem.
I don't know why it says that. For me it says like the slash. I think that sign, it says invalid option. I don't know why.
I'm getting the same error as well.
Right here?
No. When you put the ls and then the sign, like, yeah, exactly that one. Yeah.
So make sure this is a tilde. That's the squiggly character above the tab usually, or next to the one key. It's not a dash.
No. The one next to it.
Here?
Oh, no. It was okay where you were. The thing before the point. I don't know. Oh, or is it one thing like that one? Yeah, exactly.
The /.
Yeah, it tells me invalid option.
Esteban, if you use the squiggly dash, it works for me now.
Yeah, if
Okay.
probably what you did was //.ssh and you got
Yeah.
something like this. Yeah,
Yeah,
so
exactly. Yeah, exactly.
yeah, that's a dash. What I used was a tilde, which is a squiggly line.
Oh, okay.
Yep. Yeah, it's
Okay,
not very easy to see the difference on the terminal. Sorry.
Okay, great. Thank you.
Yep. Okay. So over here, we have a space for the title. The title is literally just whatever you want to call this. I'm going to call this NeuroHackademy Jupyter key. That's just a name for you. It's not important really what that is. And then down in this key box, I'm just going to paste that line that I copied. And that's pretty much all you have to do. Once you've got that, you just push add SSH keys. Well, wait here for a second to make sure everyone is able to get that for you. Okay. I'm going to push that. I need to re-verify. Okay. And then you can see the NeuroHackademy Jupyter Hub key right here. You should be able to see it on yours as well once you've done that. Does anyone have any trouble with that? Yeah. So if you type it like this, it shouldn't matter what folder you're in because the tilde stands for your home directory. Let's see, is it possible that you forgot the tilde or you forgot the slash? So when you ran the keygen algorithm, did you get this message okay?
I didn't get my directory.
Okay, let me just come take a look real quick.
Because you won't need anything else.
Yeah.
Oh. Yeah, so, go ahead. I'm here. And then
Okay, and yeah.
User at the MacBook.
Uh-huh.
Dot local, is there? Should
Dot-
that matter? Should I?
Dot local, you mean in the prompt?
When you're saving the SSH key, that you copy and paste,
Yep.
how you got the.
Oh, yeah. This little string here, if that's different, don't worry about it.
Okay.
Yeah,
Like for use, it doesn't matter.
won't matter.
Okay.
Yeah. Now I should say that just. Oh, go ahead.
No, sorry again. I'm really struggling. I don't find a way of getting there. I'm still in that part where I cannot, like, in that LS part. Yeah, I don't know. It says now curriculum shared, like shared rewrite, Zoom, something about Zoom. I don't know why. So that's that's LS, and then that sign is like the, how do you call that sign? Sorry.
So if this command is not working, try doing this instead. ls space $ home /.ssh.
Okay, that one worked. Yeah.
Okay, and then just instead of that next command, you do $home /.ssh/id _ed25519.pub, and that should also work the same way.
Okay. That one is working. Okay, thank you very much
great.
for that. Sorry.
Yeah, no problem. Okay. This section never goes right for everyone, so this is totally par for the course. Anyone else having trouble getting this to get started? Okay, and just as a quick reminder, once you've got that once you've got this line copied, go ahead and go over here and push new SSH key, give it whatever title you want, and then paste that line into the bigger dialog box and click the button at the bottom and you should get back here. Now, what we've done just now is we've generated a key on the Jupyter Hub in your directory in the Jupyter Hub, and we've told GitHub what the public key is. And what this means is that your Jupyter Hub instance can now log into GitHub using the Git command line without any trouble. And you won't even have to, like, it's not even going to ask you to authenticate, it's just going to know it's you. That said, if you now go to another computer or your own laptop not in the Jupyter Hub, you're not going to have that private key file, and so GitHub is not going to know who you are. So if you need to use this on another computer, you need to go through that process again on that computer and make sure GitHub has a copy of the public key you generate for that computer. And that's why you see I've got like 3 of these here, is because I use GitHub on different computers. And so I need to have each computer have a public key and its own private key. Okay. So all of that is the really fun stuff that is just really configuration. So we can now go back to actually thinking about GitHub. So there's a lot of ways to use Git and GitHub. And the ways that people use it has evolved quite a bit over the years. It used to be that the main use for Git was to just track files on your local computer and make sure you didn't get versions of things messed up. These days, GitHub is used for collaboration and saving your code and publishing your code. And so most people operate kind of primarily out of GitHub, and they do the editing on their computer, but GitHub is really where everything is stored and based. So when I work on code for my libraries, I typically start by pulling whatever the state is down from GitHub, editing it, saving it, and then I push whatever my changes are back up to GitHub. And that's kind of how we're going to operate today. So the first thing we're going to do is we're going to stay on GitHub for now. And let's see. I'm going to click on my name to go to kind of my page here. I think you should be able to click on your name or your login name to get back to here. And even if you're not at this page, you should have a plus icon up here, somewhere in the upper right. Go ahead and click that. And what we're going to do is we're going to make a new repository. And you should, when you click that, you should get a page come like this. Make it a little bigger. This is for creating a new repository. We're not going to use a template. You can often, templates are things people publish that say like, oh, you want to get a repository that looks like a Python library or that kind of thing. We're just going to not worry about that for now. But we're going to need a repository name. And typically when, in NeuroHackademy at least, we're usually using repositories that deal with code. But for this lesson today, we're not going to worry about code specifically. I'm just going to assume you can all extrapolate to code. Instead, we're going to worry about recipes. So this is going to be a Git repository that tracks recipes for things. So we're going to call it recipes. And I'll just warn you that if you go through this tutorial over here, the software carpentry version of the tutorial, they have a really bizarre repository about Dracula and the Mummy and Wolfman looking at planets for a base. And so I've changed that one to recipes. This description is just information for people who come to look at the repository. So I'm just going to say it's a repository for recipes. We'll leave this public. You can have as many public repositories as you want, and they're free. Private repositories, you typically have to be a paying member to have more than 1 or 2, I think. But we work in open source mostly, so we like public repositories anyway. We're not going to have a README file or any of these things for now. Although I would advise you in general, when you make a repository, to pick a license if it's got code in it. But this is not a code repository. We're just not going to worry about it. So once you've put in a name and a description here, you can just push this big create repository button at the bottom.
I have a question.
Okay. Yeah, go ahead.
In general, how would you choose your license from that list?
That's a really good question. So most of the licenses in that list are open source licenses of various kinds, and there are various kinds of open source licenses. One big category is like the MIT and BSD license, which are basically they say that whoever wrote this code is not liable for problems you have while running it, but you are free to use it in whatever capacity you want, as long as you give them credit for it. There is another set of licenses, like the GNU public license, which basically says the same thing, but in addition, if you use their code, you need to also publish your code as under the GNU public license. And then there are more restrictive licenses that say things like I reserve rights to my code and you can't use them without my permission. In general, for like, if you're doing a NeuroHackademy project, my advice is to use something like an MIT or a BSD license. That's the most restrictive and lets other people use your code however they want, more or less. But that honestly is like we could have a whole lecture on open source licenses, and I wouldn't be qualified to teach it. So that's a kind of high level overview of them. But great question. Okay, so we now you'll notice that you're at github.com/your-username/recipes. And in fact, if you go to this website here, github.com/Noah Benson/recipes, you'll see this page for my recipes repository. We all now have our own individual copies of of unique recipes repositories. And you should see something like this. This is essentially telling you how to get set up on the command line, and that's what we're going to do next. So once you get to this page, we're set for now in github.com, and we're going to go back over to the terminal. Okay. So I'm here in my terminal. I'm going to type CD. When you type CD without any arguments, it goes back to your home directory. I was already there, but just in case you were somewhere else. We're going to use a command, git clone, git at github.com : and then you put your username. So I'm going to put Noah Benson, but you should put yours there. Don't just copy mine. /recipes.git. Now the git clone command goes up to GitHub, and it takes whatever repository you tell it, whatever repository you type here, and it clones the whole thing into a local directory right here called recipes. Now, when we type that, it's probably going to say something like you've cloned an empty repository. That's true. We did just clone an empty repository, but that's okay. If I now type ls, you can see that in addition to the curriculum and shared, etc. directories, there's a recipes directory. So I'm going to cd space recipes. And if I ls in here, I'll see that there doesn't seem to be anything in here. So it seems like just an empty directory. However, it's not actually an empty directory. If I type ls-a, which shows you all files, including hidden files, you'll see that there's actually a directory here called .git. And if I do ls.git, there's some stuff in here that has to do with your GitHub repository. Basically, this .git directory is a hidden directory where Git keeps track of the state of your repository locally. And we're not going to worry too much about the .git directory. You really almost never have to look at anything in there or worry about it. But just want to alert you that it's there. And if you are wondering if something is a Git repository, you can always look at that. Okay. Did anyone have trouble cloning? What did you get? Okay. If you got something that said authenticity of host, here's a bunch of gobbledygook. Is this okay? Like yes, no, say yes. Yeah, sorry, I totally forgot about that. Basically, what's happening there is that because of this public key system, when you go up and ask GitHub, or when you go up and ask and send like a message to GitHub, it's going to send you back its public key so that you can talk to it in an encrypted way. And in theory, somebody between here and github.com could have like spliced some internet wires and intercepted your message and sent a fake message back with their own public key and then pretend to be GitHub. That's a very, very rare kind of attack, and it's almost certainly not happening between the Jupyter Hub and GitHub. And so we're not worried about it, but that's what that warning is about. It's basically saying, in theory, it's possible that someone could have hijacked your internet connection because I don't know how to verify that GitHub is who they say they are, but it's fine. It's not an actual issue. And doing that once, you should never have to do it again. So I'll give everyone a second to just do that again, and I'll highlight the command here, git clone. Okay. All right. Anyone still having trouble?
Yeah, so I cloned and went back to my home directory, and the recipes folder isn't
Were you maybe in your .ssh directory when you typed the clone command? So if you don't see it, so did it run this cloning and give you this warning?
Yeah.
I would just try running it again and see if it makes the directory. My guess is it just made it somewhere weird. Anyone else have trouble? Yeah. So is it possible that you typed the git clone command twice, or you ran it twice?
Yeah.
Yeah, okay, so that's why for that in that case. Yeah, so if you can so you can give this like another argument that says like, oh, I've already got a recipes directory, new recipes, and it'll check it out into that directory, into a new recipes directory. But and so it won't override a directory if it already exists. That's basically what it's telling you. Okay, anyone else still not have recipes cloned? Yeah. Okay. So if you go back to the GitHub page, it will actually tell you exactly what that website should be right here. So if it's not working, try copying this. And then going over to your command line and running git clone and then just pasting that. That, oh, sorry. That work? Okay, great. All right. Okay, I realized there was one configuration thing that we forgot to edit. So we're going to do one more git config command. Git config -- global. Make sure I've got this right. Yeah, okay. We're going to config core.editor nano. Now, if you have a favorite editor, if you love VI or Emacs or something, you can put that here if you want. I'm actually not sure if Emacs is installed on the hub, but if you have a favorite editor that you know is a Unix command line editor, you can put it here. If you really like VS Code, that's not supported in the Unix command line. Sorry. But Nano is basically a very simple text editor that is almost always installed on command lines like this. So we're just going to use it. It's adequate for our purposes here. Honestly, it's a fine editor. There's nothing wrong with it. So I'm going to run that. Okay. So I'm going to cd into recipes if you're not already there. Okay. So let's start with some very basic commands. The first one, and one of the most commonly used commands for me, is git status. And basically it tells you a little bit about the current repository you're in, whatever directory you're in, that repository. So what this is telling us is we're on branch main. Branches were that thing that I mentioned earlier, that like you can have multiple copies of a repository while you edit kind of different features. We currently just have one branch and we will just operate on one branch. Multiple branches is a bit more of an advanced topic, so we'll be used to seeing this line pretty often. It says we have no commits yet and we have nothing to commit. What that means is that we haven't done anything in this repository. It's just empty. Okay, so let's do something. I'm going to go ahead and make a directory called snacks and cd into snacks. And then I'm going to type nano to start this text editor. And we're going to do guacamole text for a recipe for guacamole. Yeah.
I'm not in the lead branch.
Are you in a master branch? When you typed git status, Sorry.
If that's fatal, this operation must be run.
Did you not run CD space recipes? Yeah, so a lot of the Git commands will only work if you're in a directory that is a Git repository. So that's what's going on, I think. Yeah.
I prematurely entered Nano. How do I exit?
If you mean before you typed guacamole?
Yeah.
Okay, push Control X.
Okay.
Yeah. It's worse for VI. For VI, it's something like Control Q exclamation mark. Or colon Q exclamation mark, I think. Anyway. Once you've typed out nano guacamole, if you're in this recipe snacks directory, you can type nano guacamole.txt and go ahead and push enter. And you'll get something like this screen. Okay, so real quick, I'm going to explain nano. So at the bottom is basically kind of like a menu or just like a guide. These little character sequences in black with the caret followed by like X. That caret is a representation of the control key. And if you look, most keyboards control keys have a little caret on them. So what that's saying is that if you want to exit, you push Control X. If you want to write out the file you're editing, you push Control O. That's basically what these say. So we'll use those to kind of move around in Nano. Okay, so we're making a recipe for guacamole. I'm just going to start by listing the ingredients. We'll say avocados, onions, cilantro, salt, lime. Now, that's a start. That's not the whole recipe, but we're going to start with that. I'm going to push Control and then O to write out this file. And it gives me a little prompt here. What file name do I want to write out? Guacamole.txt. That's fine. So I can just push enter. And it says wrote 7 lines here in kind of the bottom middle. And now I've saved the file, so I can go ahead and quit Nano, and I just push Control X to do that. Yeah. I just enter. It'll prompt you for like, is guacamole.txt an okay file name? You can just push enter. After what? Control X to exit. Yeah. No, Nano is, there's many versions of Nano, not just one. And Pico is a even smaller version of Nano. So that's fine. It's all the same. We're really not going to use advanced features of Nano in this lecture. So that should be fine. Yeah.
What were we supposed to press after Control O?
So it prompts you, is guacamole.txt and okay, and you can just push enter. It should at the bottom give you a prompt like, is this file name okay? And then once you push enter, it should say wrote 7 lines or something like that. And you can, once you see that, you can just push Control X to exit. If it gives you a warning about,
Sorry, no,
sure?
can you repeat that part? Sorry, no, can you repeat that part again? I finished writing down the ingredients, so now what I have to do? What do I have to do?
So Control O to write out the file, and then you push enter when it prompts you for guacamole.txt being okay. And once it says wrote 7 lines at the bottom or something like that, then you can push Control X. Yeah.
Okay, great. Thank you. Sorry.
Okay, great. So at this point, we should be back here at the prompt after you've exited Nano. Okay, so let's rerun that git status. So again, we see on branch main, no commits yet. And now it says untracked files. So it didn't say this before. And it's got this little line about using git add, which we'll get to in just a second. And it just says /. Now, the reason it says // is an untracked file is because I haven't told Git about this snacks directory, which is the directory I'm in. It's the directory dot. So as a reminder, in Unix and Linux, dot always refers to your current directory. So if I just did ls dot, it's the same as typing ls. So when it's saying // is untracked, it's saying that the directory you're in right now, I don't know what that is. Okay, so it says we can git add file to include a file. So let's go ahead and run that. So we're going to say git add guacamole.txt. And then we'll push enter. Now, what we've done just now is we've told Git that there's this file guacamole.txt. And when we add it, you would think that we're adding it to the repository, but we're actually just taking an initial step towards adding it to the repository. And this is Git has a bit of vocabulary around these concepts. Basically, what we're doing is adding guacamole.txt to what's called the staging area in Git. Now, why would we have a staging area and not just add the file into Git? The reason is because a lot of times when you're working on something, like especially when you're working on source code, there'll be a whole bunch of files and you'll go through and you'll make changes to like 5 of them because you're adding some new feature and you need to add some code in all 5 of these files for that feature to be ready. What we kind of like for people to be able to do is to take those 5 files, add them to what's called a staging area, and then commit them to the repository with a single message saying, here's what I did. I wrote this feature, I touched all these files. They're all part of one commit to the repository. So that's why we have this staging area, and that's why we have this initial step to add files before we commit them to the repository. So the vocabulary is a little confusing, but that's just how it is. So we start by adding a file, and we can add multiple files. We can now add another file. We're just going to do one for now, but you could add lots of files and then commit them. So we've added a file. If we say git status now, it's going to say, hey, here's a change you've added that's ready to be committed. This new file guacamole.txt. Okay, so now we're going to git commit. Now there's multiple ways you can run git commit. We're going to do all of them today, or at least a couple of them today. So we'll start by just running it like this, git commit. What that's going to do is open up Nano. And the reason is because when you commit something into the repository, when you're actually changing the repository by adding new stuff or by changing files, you should always write a commit message that says what you did. Now, in this case, it's pretty self-explanatory. We added a file called guacamole in our recipes repository. You probably know what I'm doing, but I'm just going to write a commit message anyway as a good example. So I'm going to say added the beginning of a recipe for guacamole. All of these lines with the pound signs, they're going to get ignored. They're not part of the commit message. They're just telling you what's happening in this commit. So once you've typed your message, you can push Control-O again to write out the commit. And again, it prompts you at the bottom for the file name, and you can just push enter. It's going to be the correct file name. And then once you've done that, you can push Control-X to exit out again. So again, that's once you've written your commit message, Control-O, then enter, then Control-X to get it out of the banana. Okay, so now it says 1 file changed, 7 insertions. That refers to, I believe, the 7 lines I added. It's got this create mode, blah, blah, blah. This is telling us something about the permissions of the file and the file system that's not really important right now. And the file, snacks/guacamole. Okay, now if I type git status, it says you're on branch main. Branch is based on origin main, but the upstream is gone. We'll come back to that in a bit. Nothing to commit, working tree clean. Okay, that's because when you commit, you tell Git that you want whatever's changed, whatever you've added, to become a permanent part of the repository. So that is now a permanent part of the record of this Git repository. And although we can delete the file guacamole.txt out of the current state of the repository, the record of that file is always going to be there. So remember how I said earlier, what Git does is it saves patches, it saves changes as you go. It doesn't actually change the files, it saves the changes you're adding. The same is true when you delete a file. It doesn't actually delete it. It notes that you've deleted it as like a change, and the original file is still somewhere in your repository. So we'll see some of that later. For now, we're going to look at a couple other commands here. First of all, a very handy command is git log. And when we type this, you'll notice that it gives us this line commit, and then another string of gobbledygook, and then a little bit of information about whatever that commit was, including the message that I typed in the commit message. Now, this is the only commit we've made to this repository, so it's the only thing that shows up when we type git log. Are you guys having trouble with something?
Yeah, I'm trapped in the nano.
Oh boy.
I can't get out. I'm sorry.
You're not a nano, you're a PI.
How did I get there? Get me out.
Okay, so how does the defense commit type config still start from global? Space, when that space, what is it, core dot editor? Yeah, core dot editor. Yeah. That should. Anyone else have that?
Oh, great, amazing, great, thank you. Is it not your lab master?
No, not this.
All right, we're gonna fix it, it's all good.
All right.
Okay. Yeah, if you end up in a screen with a lot of tildes going all the way down it, that means you're in VI, and I think to get out, you push Control Q exclamation mark enter. Real intuitive. But that's VI. Okay. All right. So this is a pretty simple log right now. It's just got this information for one commit. So let's go ahead and make some more commits, and then we'll kind of see what the log kind of tells us. So we just have this one file, but we're going to go ahead and edit it again. So go ahead and type nano guacamole.txt once more. And you can use your arrow keys in nano to navigate around. So I'm just going to go down to the bottom of the file, and I'm going to say instructions. 1, mash avocados. 2, chop onions. 3, chop cilantro. 4, squeeze limes. 5, mix everything together. Okay. Pretty basic recipe for guacamole, but it works. Once you've added these instructions, you can go ahead and Control O to write it out again. It's okay if you don't put exactly the instructions I do, just, you know, you can have your own guacamole recipe if you want. Yeah.
Sorry, when I said the nano guacamole, that's all my ingredients, that's not there, you know?
Is it possible you mistyped guacamole.txt? Go ahead and, if you're not sure, you should be able to type nano space G and then push tab. And it will autocomplete the file. Yeah.
Can you go back to your
Command line.
yeah.
Let me just save this. I'm going to Control W to write this out, and then Control X. You wanted to see this?
Yes.
Yeah.
I'm back.
You're back. Okay, no problem. All right, so I'll give everyone a second to write your own guacamole recipe. And then we're going to run git status. And now the message is a little different than before. And the reason is because we now have added and committed this file, so it's a part of the repository. So instead of saying whatever it said earlier, there's a new file, guacamole.txt, it's now saying you've modified guacamole.txt. So we have modified guacamole.txt, so that seems appropriate. So let's go ahead and git added again. Git add guacamole.txt. And then we're going to do git commits, but this time we're going to run it differently. If you have a real simple commit message, a lot of times you don't want to go all the way into an editor and edit it and then exit. you can type -m for message. And then typically in single quotes, I'll write whatever message. And if it's a short one, this is good. So added instructions for guacamole. Just be careful if you put like, if you have like don't or something inside of your string and you use an apostrophe, you'll end that single quote string. Just watch out for that. But basically, we can git commit with this message and it will skip going into nano. And we'll get that commit message here, or that commit output message here. Okay, and now if we type git status, again, we see nothing to commit, working branches clean. So we've committed that now. And if we type git log, we'll now see that there are 2 commits. And we'll see that the most recent commit is on top, added instructions for guacamole, and the beginning of the recipe is below it. So I'll pause here for a second, just in case people want to catch up. But what you can see here is that as we're changing this file, these commit messages are kind of logging what we're doing and when it happens. And furthermore, they log what files have changed and exactly what the changes are. So even though we're just seeing the messages here, Git's keeping track of everything that's changed. That's a good question. No. So in theory, there are ways to get around a lot of these restrictions in Git, but in general, once you've committed something, it's difficult to change it, including the message. And the reason for that is because to a large extent, Git is intended for lots of people to be working on the same repository. So if you commit something and it goes up to GitHub and then your collaborators will download it and start working on it, and then you say, oh, shoot, I shouldn't have done that. I'm going to undo that commit. Well, they may be several commits ahead now, and they may have done stuff that depends on your commit. So although you can say something like, I want to erase guacamole.txt from the repository, and it will no longer appear in this directory as a file, that commit you committed will stay in there, and it'll instead commit a deletion later.
Oh, I mean, more like that comment.
Just the message, you mean?
Yes, if you have all the files, maybe you realize you were not specific enough with the message.
Yeah, so if in general, I don't think you can change the commit message either. I think it's like a kind of concrete part of the commit. I could be wrong about that. I've just never had to do it, to be honest. But in general, it's just frowned upon to change past commits. If you felt like you did that, you could always commit. Well, I guess you could commit a new commit that was just empty, but to be honest, I've never really had that happen. And I'm going to say just it's always a good idea to make really good commit messages and to detail everything you've done and all that kind of stuff. There are great examples of good commit messages online you can find. However, the reality is that a lot of people don't do very good commit messages most of the time. And so it's hard for me to imagine most programmers deciding to go edit the commit message they just made, because a good chunk of commit messages on GitHub are just things like, I don't know. So, yes, that's a good question, but I don't know a way offhand to change the commit message. Yeah, these commit messages are kind of like code comments. They help you know what you, or help you remember what you were doing. Yeah. Okay. All right. So let's, okay, any questions so far? Oh yeah, go ahead. No. We haven't, we have not told GitHub about any of this yet. We are just doing things locally on our computer so far. So we'll get there, I promise. Actually, maybe we'll get there now because time's going by fast. All right. Okay, so we'll come back to this git log command and some of this kind of stuff, but I do think we should talk about GitHub. So it's a good question. Okay, so if we want to send things up to GitHub, there's a command called git push. And typically you can just run git push, and I'm actually not sure if this is going to work when we run it. I think it might complain. Nope, it's going to work. Okay, great. So that's really as complicated as it is most of the time. You wanna send something up to GitHub, you want to git push. Push just means send it upstream to wherever your like online permanent version of the repository is. Okay, so I pushed this, but what does that actually mean? Well, let's go back over to my GitHub page. And this is still in the state we left it in, but I'm just going to reload this. Again, this is github.com/my username, that is, /recipes. And that's just the site for this, this GitHub repository. If I reload this now, you'll see that instead of that message about how to set up my GitHub repository on my local computer, there's now this directory snacks. And if I go in here, there's guacamole.txt. And if I click on this, you can see what the recipe I've been writing so far. And you should all be able to do the same thing on your GitHub repositories. And yeah.
Curious about the mission specify, like just this particular document.
Okay, so there are things you can specify in the push, but that's not one of them. So you typically can't specify just this document. I think you might be able to specify just these commits. However, that's a very uncommon use of the push command. So I don't know how to do it off the top of my head. Yeah, push is really about keeping separate copies or separate servers that have the repository in sync with each other. So it doesn't really like it when you restrict what it's doing. Yeah.
That was a great question, actually. So what if I pulled a project that we're all working on, but I want, I'm working on a single file, and that's what I want to share with others.
Yeah, so in that case, you would probably git pull, edit the file, make a commit with just that file, and then push that back, and it would just push that one commit. We'll do an example of that here in just a second.
That's what you're pushing, not the entire local.
Yeah, so that's a good question. And just in case people on Zoom are having trouble hearing, whatever you committed is what you're pushing, or is it the whole repository? It's both. So, and the reason is because of that change thing, that the way Git saves things in terms of changes or diffs. So if you pull a GitHub repository down and you edit a file, your computer has a copy of the whole repository, and it saves that edit as a new change on top of that copy. And then when you push, it goes and it looks at the state of the repository on GitHub and says, hey, we're identical up to this point, except I've got one more commit than you do. So let me just send that commit up to GitHub.
So I would concurrently pull any changes anyone else made to other files.
When you, okay, so you're getting a little ahead of us because that's concurrent editing. But yeah, the idea here is that you can grant other people permissions. So like I could go in and say, some of you have permission to edit my recipes repository, and then you could all clone my repository, make changes, and push those commits up to GitHub. And then those commits would show up here, and I would come back over to my command line, and I could pull them down. Let me just show you how to do that, but with a slightly different use case. Go ahead.
Actually, I didn't want to do that if I don't have to. How do I do next week if I'm working with someone? Just what is the best way to not mess up anything and only push my cycle?
What we just did will do the right thing almost all the time. So in terms of if you're worried about messing up someone else's repository, yeah, okay. So so again, to repeat just for the Zoom people, the question is basically how to make sure that when you're collaborating with people on a repository, you don't screw up the state order of the repository for other people. And the simple answer to that for 99% of the use cases is that Git will handle that for you and will make sure that things don't get messed up. And if it's going to mess things up, it will give you a big warning first. And we can walk through an example of this right now, actually. So I just want to point out, first of all, that this GitHub website has a lot of really useful things built in. And in fact, we can totally do everything we just did on the command line here on the website. So stay here on the website. You see this little pencil button over here? Go ahead and click on that button to edit this file. So over here, we have the same file. I'm just going to use this editor here, and I'm going to say, we're going to add tomatoes. And I'm gonna chop the tomatoes and then renumber these so they're correct. And there, now I've made a couple changes here. And I can go up here and I can either cancel these changes or I can commit the changes. And if I push this commit button, it's going to ask me to put in a commit message. You can have, this is a place for a longer commit message if you want. And update guacamole.txt, that's fine. I'm actually going to change this to added tomatoes. And we can commit directly to the main branch. Again, we're not going to do much with branches today. And then I can commit these changes. Okay, so now the official version of guacamole.txt has the tomatoes in it. But if I go over here, back to my terminal, and I just cat that guacamole file, tomatoes isn't here yet, because this is the copy on my local computer. It's not the copy on github.com. So if we use git push to push things up to GitHub, then we have to use git pull to pull things down. So you can just type git pull. And you see here that it says, embedded in this message about what it's doing, snack/guacamole.txt, and it's got these little pluses and minuses after it. Basically, it's telling us that it's pulling down a new version of guacamole.txt. And now, if we cat guacamole.txt, we see that there's tomatoes in both spots. So basically what we did was we made an edit. We just made the edit up on the website instead of on our local computer. And then we told our local computer to sync itself with the website. Now, again, if you're collaborating with a bunch of people, what you might be doing is you might all have permission to edit this repository. And you might be editing things locally and then pushing them up. Someone else might be doing the same thing, and then you would pull their changes down. Whether you make an edit in the website or you make an edit on your local computer, it's the same as far as Git is concerned. And in fact, if we go back over to the terminal and we now type git log, we'll see that there are 3 commits, one of which is the added tomatoes that we did online. Yeah.
Is there a way to see edits have been made elsewhere? Because I tried to get status, but it didn't show.
Yes. So I believe you can type git fetch and it will pull down the repository without replacing your current directory state. But honestly, that's not something I do very often, so I'm not sure offhand what the correct answer is. I think if you type git fetch and then git status, it will tell you you're behind main by a commit, something like that. But I could be wrong about that. Okay, that work? Okay, great. Yeah, git fetch is basically like git pull, but it says go and sync yourself with the repository, but don't change my current directory. Keep it the way it is.
No,
Okay.
no, sorry. Just one question. For example, if we don't create an authentication key and we create and we want to do the git push.
Mm-hmm.
From what I'm reading here, an option and something that can happen is that it will ask you for a username and password, but apparently that's not supported anymore. So you always need to have an authentication key to do all these process.
Yes, there are other ways to authenticate, but the key that we set up is the easiest. I don't believe any of the Git servers support username and password authentication anymore.
Yeah, no,
But,
no, it doesn't. So yeah, okay.
Yeah. There are other ways. I don't know how to set them up off the top of my head. There's an HTTPS authentication method that is typically a little more complicated. We use this one just because it's the easiest and is also pretty standard.
Great, thank you.
Mm-hmm. Okay. Any other questions for? Okay, I'm just going to demonstrate a couple of the things then. First of all, I just want to mention that git log has an option called one line, which is handy. It just shows you your commits on single lines. Not a big deal. Okay. So I think what we'll look at next, let's suppose I'm editing here locally. So I'm going to open up guacamole.txt. And I'm not sure, I'm going to say that I add garlic to my my recipe here. So I'm going to Control O to write that out and Control X to exit. And let's suppose that as I'm doing that, well, let's go ahead and add it. I'm going to add guacamole.txt and commits. Added garlic. Now, let's suppose I was collaborating with someone else who came over to the website and edited this file. And instead of adding garlic, I don't know, what else do people put in guacamole? What? Yeah, exactly. So instead of garlic, they put jalapenos. So I'm gonna commit that change. Okay, so now we're in a weird situation. The github.com version of the repository has jalapenos in it, in this line. My local version of the repository has garlic on the same line. We've both committed these changes to the repository, but we haven't synchronized yet. So this is an example of where things can get really confusing if two people are editing the same file at the same time. So fortunately, Git is very smart about this kind of thing. I'm going to go ahead and git push, and it's probably going to give me some kind of warning. I don't know exactly what it's going to be, but we're going to deal with it. Okay, rejected. Updates were rejected because the remote contains work that you do not have locally. So basically, the remote is the copy of the repository on github.com. It's telling me that there's things that have changed that you don't have, and I don't know how to integrate them together. So it's saying run git pull before you push again. So basically, it's saying, hey, you can't push this repository. It's got stuff you don't have. Synchronize yourself with it first, and then you can push. So we'll go ahead and get pull. Okay, so we get another message. You have divergent branches and need to specify how to reconcile them. Yeah.
If we hadn't committed before we pulled, would that have overwritten our work with the remote?
Great question. So the question was, if we haven't committed before we pulled, will it overwrite the work we've done? No, it's smarter than that. Unless, now there are command line options that will force it to overwrite, but like, typically, Git will err on the side of keeping whatever you've got and let you resolve the issue. It's pretty hard to accidentally delete a bunch of your files with Git. Yeah. What?
I've done it.
Oh.
And then I didn't touch Git for a really long time.
Okay, well, I'm sorry to hear that. Yeah. So basically, a lot of what this message is telling us about is that we need to merge our two repositories together. And it's at the end saying, fatal, you need to specify how to reconcile divergent branches. So what it's actually done is if we now type nano guacamole.txt, and I believe before I run this command, I'm going to type git status. And it's saying we have some different commits. Use git pull to merge the remote branch into yours. Okay, git pull. Oh, I'm sorry. I forgot. This is actually something that just changed in the last fairly recently, that you have to specify this option. So sorry, we should have done this earlier. Git config -- global pull .rebase. I believe we want to say false. Now we should be able to type git pull. Yeah, so the idea here is that when you're merging, there's various strategies you can have, or when you've got a conflict, there's various strategies you can have. One is to try to merge them together One is to basically take one as the base, and to be honest, I'm not totally sure what the rebase and fast forward do. But I'm fairly certain that for the uses we'll have in the NeuroHackademy, this option is not going to matter a whole lot. But now if we get pull, it's going to tell us we have a merge conflict in snacks/guacamole.txt. And it says automatic merge failed, fix conflicts, and then commit the result. Okay, so first of all, suppose that on the online repository over here, I had edited a different file. I had made a new file and I hadn't edited guacamole.txt. In that case, Git would get smart enough to automatically merge those because there's not a conflict really. We've edited different things and we can just pretend like they happened at exactly the same time and it's fine. In this case, we have a conflict specifically because we edited the same line. And it doesn't know what to do about that. It doesn't know if it should put garlic and then jalapenos or jalapenos and then garlic or just one or the other. So it's saying, I don't know how to automatically merge. You have to do it manually. So to do that, we just go to nano guacamole.txt. And you see how it is put this weird stuff around our garlic and jalapenos. Basically, what this is telling us is that we need to decide what to put here. And really all we have to do is we can just delete all of this. We can delete all of this, and we just need to make sure that when we save this file, it's however we want it to be at the end of the merge. So in this case, I think we just want to have garlic and jalapenos. And so we'll put both of them in here like this. We'll delete all those little markers that say this is a merge conflict. And then we can push Control-O to write out this file and Control-X. And now if we type git status, I think it'll tell us we're doing a merge. Yep, we have diverged branches. It says this is the modified file. We're going to git add guacamole.txt just like we had edited it, and git commits fixing merge. And now we should be able to git push. And if we go back over to our online GitHub repository and reload this, we now see that we've got garlic and jalapenos. Just real quick, I'll point out that if we go back to the main kind of page, the code page for this repository, you see this little thing over here that says 6 commits. This is basically kind of a little message from that git log command. If we click here, we're actually going to see the equivalent of the git log command. Here's all of the various commits we've made, kind of stacked on top of each other. Back here?
I'm sorry, the cheaper.
Sorry, here, yeah, sorry. I went through those commands real fast. So yeah, up here. Once you fix that merge, you git add it, git commit it, and then git push. And note that if we do git log -- one line over here, we'll see all those same fixing merge, added jalapenos, garlic, tomatoes, etc. That we see over here when we click this commits button and see all these. Okay, question?
How did you get the commits again on the website?
Yeah. So to get to the commits, you can go to the code page, which is the main page. It's just the like your username / recipes. And then there's this commits, 6 commits over here. That takes you to the log, basically. And a kind of neat thing about this log is that you can actually go over here and say, like, I want to see what the repository was like back when I committed this added tomatoes commit. And I can click on this little brackets, and it'll take me to the repository at that point in time. And I can go to the guacamole.txt and see that this is before we added garlic and jalapenos and stuff. So basically, because Git keeps track of every change we do, we can rewind it to whatever point and look at the state at that point. Okay, any questions? Yeah.
Thinking about how like I would use this as like normal like every design. Because you don't necessarily have like one file that you're working on, having more
Yeah.
if I like working on like 5 different like scripts in a day, would I, at the end of the day, have to specify that each, like, commit each one separately and then write out the text?
Yeah, great question. So in general, so for people on Zoom who maybe couldn't hear, suppose you're working on like 5 files as part of a larger project and you've spent a day working on them. Do you need to commit them each separately? The answer is no. So just as a very quick example, I don't know. I'm going to make a recipe cookies.txt. We're just going to say to do. I'm going to write that out and exit. And now I'm going to edit guacamole.txt. I'm going to go, whoops, I'm going to go down to the bottom and add in that we need to chop garlic, chop. Write that out and exit. Now, if I type git status, I see that there's a new file and a modified file. And now guacamole and cookies are not really related, but they're not really, they usually wouldn't be the same commit, but let's just pretend that this is all part of the same commit. Like I was adding a single feature to this recipe book. I would just git add cookies.txt and git add guacamole.txt. And then when I git commit, you notice that it says changes to be committed, cookies.txt and guacamole.txt. So this commit will actually have multiple files in it. It's going to have a change in guacamole and it's going to have a new file cookies. And so my commit message should probably be something like, edited and added cookie placeholder. Then I can write that out and exit. And if I git push, it should show up here on the recipes as cookies. So yeah, you often, the whole reason we have that staging area and the git add command is so that you can bundle a bunch of changes in different files across your repository into a single commit that kind of conceptually goes together. And that can be really useful because a lot of times in a code base, you can edit one file, and if you commit that file by itself, the repository is broken because that file has things that other files depend on in the code base. But if you edit all 5 of the files and you commit them together, then when I come to pull your changes down, I won't accidentally pull down half of them. I'll only pull down that commit altogether or not. But that's a great question. Okay, we're basically at time. Yeah, no problem. That's a great question too. So is it possible to use Git for papers with co-authors? Yes and no. So we've been working with text here, and most code is text, and Git is really good at text. When you start to get into files that aren't text, that are like Word documents, it doesn't do very well because those files change in very unpredictable ways when you modify them. So these kinds of heuristics for merging changes in text files work well for text files and not for Word documents. So if you're going to edit a paper with colleagues and you're going to use Word or Pages or something like that, use the collaboration features in that tool. Don't try to use GitHub for it. If you want to edit a paper in GitHub, you need to use a language like LaTeX. So LaTeX is if what you want to do when you write a paper is write in a programming language, LaTeX is for you. It's sort of it's a way, well, I won't get into it, but it's a text-based way to format documents. It's a lot of people love it. It's very powerful. If you want to do things in Git using it, you can absolutely do LaTeX in Git. There's also a website called Overleaf that does LaTeX-based papers that can be kind of nice for collaborating. A lot of people like that a lot more. It's much easier to use. But in general, I wouldn't put files that aren't text in GitHub unless you really need to. GitHub is not great for storing data files. And there are various reasons for that. But it's good for storing text files. So in general, it's great for code, not so great for data. Yeah.
Is there a way that you can like copy all of the commands that you put in the terminal into like a text file for us so that we can have it?
Oh, I can. And actually, let me see if I can show you this trick. History. So you can type history yourself. And if you want, you can type history. Oops, history arrow, history.txt. That little arrow says take whatever this command does and save it into this file. So yeah, that's what I would do there. This probably grabbed a bunch of my previous commands that don't make sense as well. So yeah.
So when you're working with code, obviously you wanna test your code that it works, right? Especially if I'm working in MATLAB, I'm not gonna go into Nano and copy and paste everything, right? Or how do you like?
Oh yeah. So if you're like working in MATLAB and you edit your files in MATLAB, that's fine. You don't need to go put them in Nano. They're already files in your directory, right? There you've saved these .in files. And you can just add and commit them. Yeah, yeah. Right. Nano is not integral to any of this. It's just the editor we use to make the files. So if MATLAB is your editor, use MATLAB. Yeah. Yeah.
In an ideal world, how often would you commit and push?
That's a great question. I probably should have said it voluntarily. So for people on Zoom, it was in an ideal world, how often should you commit and push? So I try to commit every time I've finished a block of work that is self-contained. Sometimes that means I don't commit for a few days. Sometimes that means I commit several times now. It just depends on like, once I've got a unit of work that's kind of finished in and of itself, I'll commit it. So it really depends. As for pushing, there's not, honestly, there's not a good reason not to just push all the time. It's not like it's taking up a lot of CPU or anything like that. But it's kind of when it has much as you're comfortable. You know, if you feel like your computer is going to lose your work somehow, push all the time. If you're not worried about that, just push often enough that you've got it.
Around the time being pushed out for you today.
Yeah. Yeah. Yep. Yeah, push just synchronizes things. It doesn't make entries in your log or anything like that. It's just a synchronization command. Yeah.
I'm just curious about overleaf. So, so for you to use overleaf on algorithm, if your goal is to use overleaf, or can you convert words to overleaf and then?
Okay, so with Overleaf, I don't use Overleaf a whole lot. I've used it a few times. I believe that if you have a subscription to Overleaf, you can invite people to work on your paper with you without them having an account. If they want to work in Word, you need to take that up with them. I don't think Overleaf is good at transforming between Word and LaTeX. I just don't think anything's very good at that. Yeah. Yeah.
I would spend a lot of money on using that only when I'm doing those.
Yeah.
But I do that and probably see it.
Yes, and we didn't, honestly, this is like a 4-hour lesson that we just tried to do in an hour and a half, so we didn't get to that. But there are a couple commands. One is git revert and one is git reset. They have different uses. Revert is for when you want to add basically a commit to the repository that says, I'm going back to this point or I'm deleting these things. Git reset will actually take you back to that point in the repository, like it will almost like discard the new changes, but that causes lots of problems when you try to merge because it doesn't like github.com already has those changes. So trying to push them up to GitHub will cause problems. And to be honest, this is where Git starts to get very complicated because there's a lot of features that are designed to make sure that this works across great big organizations. And so I would need to look at some help files and stuff to be sure how to tell you how to do that correctly. The short answer is it's possible, and Google is your friend for that kind of thing. Yeah, in general, Google is great for Git. So many people use it nowadays that pretty much anything you Google will be have a nice recipe on Stack Exchange. Yeah.
No, sorry, I have a couple of really short questions. I think.
Yeah, no problem.
The first one, is it possible to, for example, to change the name of the document? For example, if I want to change it from guacamole to, I don't know, guacamole mix, I don't know. Is it possible to do that? Probably yes, right?
Yep. Can you see what I'm typing right now?
Yeah. Okay. Okay.
That will move it, and then you have to commit that. You have to add and commit that change, but you can do it that way. Absolutely.
Okay, and the second question, is this the only way to upload this kind of like documents to GitHub, or is it possible to do it from GitHub as well?
Oh boy, I think you can upload straight into GitHub. I've never done it because I've never found that to be a very convenient way to do it. But I would Google that, to be honest. I don't know offhand if there's an easy way to do it. I think
Okay,
Git push
so-
is the easiest.
Okay,
yeah.
so this would be the way to actually, if I want to add anything to my GitHub, I have to do it through this way, right?
This is how I would advise doing it for sure.
Okay, great, thank you.
Great. All right, thanks everyone. We're way past time. I'll stick around here for a little while. If people have more questions, happy to answer them. Yeah, thanks.
No, now
Yep.
that everything is finished, can I ask you another question?
Yeah.